All right, guys. This is it. Okay. We've really reached the end here. We are taking a look at our final exam review packet. I plan on making a series of these videos, so if we don't get through every question today, just a little bit here, please don't freak out. I promise I'll make them all. Take a little bit of time. We'll get there. Okay. Again, your open-ended final is this Thursday. Your calculator multiple choice part is Friday, and your non-calculator multiple choice part is on Monday, the following Monday. Okay? All right, here we go. Which figure below is not a polygon? A polygon needs straight sides and no curves. Okay, but it also has to be just one figure. So notice that D, C, and B are all okay. We got ourselves a hexagon, a quadrilateral, okay, so on. I think this is a decagon off the top of my head. But A is not going to be a polygon because it closes off, okay, which you can't have. Perfect. Figure below is I heard a lot of you guys saying polygon, okay? Let me see if I can focus this real quick. A little bit better. Actually, a lot better. Okay, this is a polygon, all right, but more specifically, 1, 2, 3, 4, 5, there's 5 sides, so therefore it's a pentagon. I'm going to give you guys a big hint. Make sure that you review all of your shapes like quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon. All these things are going to help you for your final. Which figure below is not a convex polygon? Convex is whenever you extend all of your sides out, that none of them go inward. Okay? Probably already noticing that I skipped B because if I make this one go in, it goes right inside there. That's concave, not convex. All right? Excellent. Which one of the figure statements below is false? A decagon has 8 angles. Well, a decagon has 10 sides, so it should have 10 angles. We're going to go ahead and kind of leave that one alone right now. A circle is not a polygon. True. Okay, so cross that off. Hexagon has 5 sides. True. Quadrilateral has 4 sides. We're going right back to where we were. Excellent. Okay. Name a polygon with 4 sides. You've got square. All sides, all angles congruent. You've got rectangle. All 4 angles are 90 degrees. You've got rhombus. Okay, you have a kite. You have a trapezoid. You have parallelograms. Just trying to give you a nice little mixed bag of them so that you guys are better off for it. Okay? Which figure below is not a regular polygon? Regular polygon means all sides, all angles are congruent. Okay? So if we're taking a look at this, here's equilateral triangle, we're good. Square, good. Hexagon, okay, all angles are good. But B is not even a polygon to begin with because it's a circle. Alrighty? That's our first page. Excellent. And as always, I know I'm going relatively fast here, but please don't hesitate to pause the video and to oops, to the back side. Pause the video and replay anything that you need to be replayed if, I'm going too fast. Okay, for a parallelogram PQLM below, if angle PML equals 83 degrees and angle PQL equals what? Well, PML is right here. So they're saying this is 83 degrees. And PQL is up in this corner. There's another 83 degrees. Okay, opposite angles in the parallelogram are congruent. Adjacent angles out to 180. They're supplementary. Very good. Find the value of the variables in the parallelogram. Well, since parallelogram, I know if this is 126, what's angle Z? You got it, 126 degrees. Now, all these sides are parallel. Don't forget about good old alternate interior angles. If this is 38 degrees, what's this? 38 degrees. And lastly, I'm trying to find why. There's multiple things you guys can do here to figure this one out. I would say probably the easiest. This is a triangle, so we know a triangle has to have to 180. So if I use my trusty calculator here, 38 plus 126, those 2 angles that are already in there, it's 164. I can take 180 minus that and get 16 degrees for my angle Y. Okay, very good. Got them all. Number 9, if ON equals 8x minus 6 and LM equals 2x plus 7, NM equals x plus 4, and OL equals 4y minus 7. Find the values of x and y. I'm going to go ahead and label everything here. Okay, 8x minus 6 up top, 2x plus 7, NM is x plus 4, and 4y minus 7 over here. Okay, it always helps to label things more visual. You get the idea. Opposite sides of a parallelogram are congruent. So I could set x plus 4 equal to 4y minus 7, but again, problem, two variables. So instead, let's do 8x minus 6 equals 2x plus 7. All right, now we're going to subtract 2x from both sides. 6x minus 6 equals 7. Okay. Add 6 over. 6x equals 13. Divide x equals 13 over 6. Okay. Now I apologize. This is not the prettiest answer in the world, but we're getting 2.13 or something along those lines. Well, now my other equation is x plus 4 equals 4y minus 7. Okay. 13 over 6 plus 4 equals 4y minus 7. Let's see here. 13 over 6 plus 4, math fraction, enter, gives me 37 over 6. Okay. I'm going to add 7 over to this. Oop, I kept it already in there for us. Very nice. So 79 over 6 equals 4y. And then last thing, I'm going to divide both sides by 4. 79 over 24. Okay? Awesome. Okay? Good. Next one, number 10. Which statement is true? All quadrilaterals are squares. This is false. Okay? There are some quadrilaterals that are squares, but not all of them. All rectangles are squares. Again, this is false because it's sometimes. A rectangle can be a square, but only if all of its sides are the same, which doesn't always happen. All quadrilaterals are parallelograms. Again, you're taking something very broad and making it very specific, so that's going to be false again. All parallelograms are quadrilaterals. Boom. That looks good because, again, a parallelogram is a four-sided figure, which is that blanket statement. Okay. For the trapezoid shown below, the measure of the midsegment is what? The midsegment is a line that cuts, okay, your trapezoid in half. So it's the average of your two outside. So I'm going to do 22 plus 36 and divide that by 2. All right. Give you a little bit of calculator work here. 22 plus 36, 58, divide by 2. Boom, got it. So 58 over 2, which then reduces down to 29. Okay? Excellent. If all four sides of a quadrilateral are congruent, the quadrilateral is, please be careful, I know we talked about this numerous times in class, but if all they're telling you is four sides are congruent, then you know it's a rhombus. Okay? You'd be inclined to say square, I get that, it makes sense, but again, you need to have four congruent angles in order for it to be a square. Okay, second page is down and we're going to move right along. A rectangular garden 42 feet by 20 feet is surrounded by a walkway of uniform width. If the total area of the garden and walkway is 1248 square feet, the width of the walkway is what? Okay, so if we take a look at this problem, we're going to first find the area of our garden. Okay, so to do that, area, garden, it's going to be 42 times 20. All right. Which gives us, 840, I believe it's feet squared. Okay, very good. Okay, now, you have the area of the inside, which right now, on top of our heads, we know we have to get an extra, let's see here, roughly around an extra 504 square feet. A simple way to do this is, we know the uniform walkway all the way around is x. Okay, so like everything's got to be the same. It's got to be an extra foot over here, extra foot over there, whatever it may be. So when we set this up, it looks something like this. 42 plus 2x is your length. And your width is 20 plus 2x. And that'll give you your area. So what we can do here is let's try a few different things. Let's try x equals 1, x equals 2, x equals 3. Okay? Meaning, 42 plus, if I put a 1 in for x, that'd just be 2, times 20 plus, put a 1 in for x, you get just 2. 968, does that give me 1,248 square feet? The answer is no. So I know the answer is not 1. All right. Now, I'm going to go back here and try for 2. If I do 2 times 2, I get 4. This gives me 4. 1104. I'm getting closer, okay, but it's still not 2. Let's try it for 3. If I put a 3 in there again for this equation, 2 times 3 is 6. 1248, boom, there we go. So the width of the walkway is 3 feet, okay? Always helps to kind of like, plug them in there and try them out. Area parallelogram is length times width, or rather base times height, okay? So our base is 40. The height is the distance perpendicular between your two bases. So I'm looking at 40 times 17 here. All right. I know that 20 is there. It will be there to throw you off. You do not need it. Multiply them together, 680 units squared. Okay. Area of a trapezoid. Area is 1/2 height times base 1 plus base 2. Again, you have to make sure you recognize what the bases are and the height is. The bases are your parallel sides. So in this case, it's 13 and 25. The height is the perpendicular distance between them. So here we're looking at our height is 20. Our base 1 and base 2 is 13 and 25. Make sure if you're using the calculator, which again I'm encouraging you to do, that you're putting it in exactly as you see it. So notice that I'm going to put 13 plus 25 completely in parentheses. Oops, sorry, there's a glare there. Okay. Now when I hit enter, 380. Are we talking about, yep, just units squared again. Okay, good. All right, find the area of the region shown by dividing into two trapezoids. Okay, so trapezoid 1, we're going to go ahead and put 1 right here and a 2 right there. It's 1/2, the height is 16. My bases are 30 and 5, so 30 plus 5. Okay, put a little 1 next to that one. And then the area for the second one is 1/2, 12 is my height. 13 plus 30. Okay, so let's take a look at this. Let's see here, 1/2, 16, 30 plus 5, 280. The other one, hit second enter to kind of pull it back up. 12, 13 plus 30, 258. And if I take these two and add them together, 258 plus 280, I get 538 units squared. Okay, last two here. In rhombus ABCD, AB is 18.77 and AC is 18. Find the area of the rhombus, the nearest tenth. Okay, so here's my rhombus. I am going to make one little switch up to this problem because I can tell you what this type problem looks like on your final. AC is 18. That's your diagonal 1. I'm going to change this to BD, okay, which is your diagonal across, because otherwise you'd use Pythagorean theorem, and for right now, we're okay. So the area of a rhombus is 1/2 D1 times D2. So we're looking at 1/2 18 times 18.77. Okay, so 1/2 18, 18.77, 168.93. And this is, again, units squared. Make sure that for area, you always have units squared. Okay, last one. Mark sold 63 tickets to school play and Nicole sold 42. What's the ratio of the number of tickets Mark sold to total number of tickets sold? Mark sold 63. Total number of tickets is 63 plus 42. So 63 plus 42, 105. So 63 divided by 105, math fraction enter. The ratio is 200, oops, I put the wrong number in, didn't I? My bad. 0.6, or a 3:5 ratio. Okay, just in time. I had 12 seconds to spare. All right, guys, keep up the good work. Good luck. We're all counting on you.